Hi, this is Specialist Gifford doing another video. The next one in our series, so converting between mixed and improper fractions. So we got our first introduction to fractions with our simple or proper fractions, or we dealt with a half or thirds. We can also deal with hundredths. So simple or proper fractions have a small number on top and a big number on the bottom, or at least a bigger number. Improper fractions are the opposite of that. They have a bigger number on top than on bottom. So like 32 over 5 is an example, 17 over 14, 11 over 10. As long as the bigger number is on top and the smaller number is on bottom, it is called an improper fraction. So top is bigger than bottom. That's what it has in common. Simple or proper, the top is smaller than the bottom. So a true part to the whole there. Mixed fractions are always a combination of a whole and a simple fraction. So it's a whole plus simple, or a true fractional part. All right, so what we're going to be mostly focusing on is how to convert between mixed and improper. There is no need to convert simple to mixed or improper. You can't. You actually would not be able to convert these to a mixed fraction there, because there is no whole part on the simple or proper fractions there. All right, so the mixed is a whole plus simple, or sometimes we think of it as like a whole plus a part. That's another way we can think about it. So maybe pause this, maybe write those things down, have something to compare it to, have some examples to compare it to before we start. All right, so one thing to consider with mixed fractions is that if we have a number like 3 1/4, that's just like saying I have 3 wholes plus. When I said plus a part, I didn't mean that figuratively. I meant that literally. You are literally adding a part to the whole. It's just like 3 1/4. It's just like how 3.25, which is the same thing as 3 1/4, is the same thing as 3 plus 0.25. If I were to add these two together, I would get back 3.25. I can add the whole plus the part. Now, decimals and fractions, they both represent parts of something. And in the next video, I do want to go over how to convert between decimals and fractions. But for now, we're just going to convert between mixed and improper. All right. So a little bit of intuition before I introduce the straightforward method here. So let's say I wanted to convert. Oh yeah, let's actually do that. 3 1/4. Let's actually convert that. So let's really pull this apart and analyze it here. Let's overanalyze it. Can't go wrong with that. You get about 6 minutes per problem anyway. I'm sure it'll take us less than that to convert this. All right, so let's think about that as 3 plus 1/4. Okay, well, let's break this apart even further here. 3 is just like saying I have 1 plus 1 plus 1. So I hope that makes sense. And then plus that fourth. And hopefully we know enough about fractions to know that 1 is equal to 4 over 4. So I'm going to go ahead and convert all my 1s into a 4 over 4. Reason being, well, I see a denominator there. I want to have something to compare it to. I want to have something like that one. All right, and then 1 becomes 4 over 4. So hopefully we understand that 4 over 4 plus 4 over 4 plus 4 over 4 is equal to 3. Simply have a whole plus a whole plus a whole, 3 wholes. Okay? And then I'm just going to bring down that 1 other fourth here. So plus that 1/4. That's our part. Okay, well, can't we just add this now? Hopefully, after watching a couple of other videos, you are able to, in fact, add these fractions up here. So we have the same denominator. There's nothing else to really consider at this point. We can just add the top parts and keep the denominator the same. All right. So I have 4 plus 4 plus 4 on top plus my 1 and all over 4. So 4 plus 4 is 8 plus 4 is 12 plus 1 is 13. 13 over 4. That is equal to 3 1/4. Okay, hopefully it made sense how we got there. If not, pause the video, go back again, see if anything makes sense, email me or schedule a session. There's definitely some important stuff that we need to master before we can move on to other concepts. And if you're already comfortable getting quicker with it, obviously it won't hurt. So we know that this is equal to 13/4. All right. So what about the method? Here, I'll go ahead and just make a note of that though. That equals 13 over 4. I'm going to erase this part here, and I want to go over the method that I want us to get comfortable with, the method I want us to use. This video is going to be pretty short. I'm not going to go over too many of these examples, but I will give you some practice problems on it. All right, so here's what I want us to do. 13 over 4 is what we got here. Here's the method. We have 3 1/4. Actually, you know what? I'm going to do the generalized version of it first. We have A as our whole and x over y. So part. We're going to have, obviously, we want y to be our denominator. And we'll have A groups of y plus whatever's on top. Boom. So let's look at 3 1/4. We have 3 times 4 plus our 1. We take these two to get that. And that 1 just translates to what we add on the end there. So 3 times 4 is 12. 12 plus 1, that's over 4. 13 over 4. Pretty quick and easy. Let's go over a couple examples more on how to do that. I'll leave this up. And then what I want us to also get used to is our generalizations. The more comfortable you get with generalizations, the more that you'll be able to generalize rules on the fly. In fact, there's sometimes in the SF I had to create my own rules for certain problems. Let's do 4 1/3. I don't want to do quite that actually. I want to go, let's go 5 3/7. All right. So multiply the denominator by the whole. So on top, we're going to have 5 times 7 plus our 3 all over 7. All right, so 7 times 5 is 35, plus 3, so 38 over 7. That's how quick that you should be able to do these conversions. Because and a lot of the problems that you're going to see in the ASVAB, you get about 6 minutes per question in the ASVAB, I'd say. So don't waste that time. Anytime you get any opportunity you have to save yourself a few seconds, take that opportunity. Let's do just one more. Let's go 10 and 9/11ths. Okay, so 10 times 11 plus 9. That should be our go-to all over 11. And you multiply 10 times something, or you just take that number you're multiplying, add a 0 to it, plus 9 over 11. And we have 119 over 11. Okay. Now, how about from mixed to, we went from mixed to improper. That's the method from mixed to improper. How about the other way? Well, let's see. We know that if we went 15 divided by 3, we know that's 5. Yeah, because 3 groups of 15, 3 equal sized groups of 15, there'd be 5 in each group. Okay, I can accept that. But then if I had 16 thirds, how much more is that than 15 thirds? That's 1/3 more. So already we already did the most of our work here. It's going to be 1/3 more than 5. It's going to be 5 1/3. Done. So then if we had 17 thirds, it's going to be 5 with 2/3 left over. If we had 18 thirds, well, 18 divided by 3, 3 goes perfectly into 8. It goes perfectly into 8 6 times. What's 1 more third? What's 5 2/3 plus 1/3? That's going to be 6. I mean, we could say 5 3/3, but what's 3/3? It's the whole. 5 plus 1 more whole is going to be 6. 6 wholes. So, if that makes sense, this gives us an idea. It seemed like whatever was on my bottom here, I'd see how many times it went into the top number, and then if I had a remainder, and hopefully you've heard of remainders before with long division, and whatever remainder was, it's just that remainder over our denominator. So, let's do an example from scratch instead of building from like that. We'll do something kind of easy. We'll go 46 over 5. Now, if you know your 5 multiples pretty well, you know that 5 does go into 45. How many times does 5 go into 45? Maybe I'll do a side note here. How many times does 5 go into 45? Goes in 9 times. So 46 over 5 will be 9, and then I just have 1 more fifth. 45 fifths, 46 fifths. I have 1 more fifth left over. However, it goes in 9 times the remainder of 1. So what we're looking for, again, maybe we can go 83 divided by 8. Hopefully we have enough number sense to know that 8 goes into 80. 8 goes into 80 10 times with the remainder of 3. How do I show the remainder of 3? Well, I was dividing by 8. 3 divided by 8. Same representation as 10 3/8. There we go. That should be enough examples for now. I'm gonna throw out some more examples there. You know what? Actually, there's maybe one example. Actually, one example in particular I want to go over. I had 1,000. 1,000 over 999. Well, I'm going to let you guys pause it for a second, see if you can solve it. Okay. 989 goes into 1,000 one time with just one left over, really. So I'm going to have, it goes in one time with one left over. That's my answer. Okay. So I'm going to put up some practice problems for this section here. Let me know if anything needs further explanation. So maybe just a quick recap. One last recap. If I had something like 29 over 6. So in essence what we're doing, that 6 goes into 29 4 times with a remainder of 5. So if you've ever done long division, you've seen something, remainder something. 6 goes into 24. Add 5 more, you get 29. The way we show that, that suggests that we have 4 and 5 6. That's how it all translates. Because this is basically a division problem. If you give me this problem and said 4 remainder 5, well, technically you're right, because I mean, if I said divide, that's correct. If I said convert this to a mixed fraction, I'd say I want to see one more step. I want to see you convert that completely. So hopefully this makes sense. I'll use practice problems, and I'll see you in the next video.